So as I said, I'm a time optimist, and I think that everything is much easier than it's actually is, and takes a lot less time. So a couple of weeks ago, writing like the presentation, like the PowerPoint, if you like, in ScalaJS seemed like a very good idea. Yesterday, it didn't feel that way, and still this morning, it was a little bit. Yeah, I was kind of regretting my choices. But please enjoy this really fancy animation here, because it's been a little bit of work. So my presentation is called Full Stack Scala, and it's always certainly going to be about writing a web application with a front end in ScalaJS and a back end in. Did I say Java? No, I said ScalaJS, right? And a backend in Scala as well. So I've done this a couple of times. First time I came into a project and I had to maintain an Angular application. And I never really got Angular 1. And I tried to really study it and try to find out what was happening there. And it was a mix between Angular and Play. So there was a lot of like server-side rendering, and then there were some pieces done in Angular that kind of messed up anything, and I really didn't get it. So I kind of silently, without asking, just introduced ScalaJS instead. It was not a very important application, but still. And it was a very good experience. And just before we had to ship it, Sebastian actually said that ScalaJS is now production ready. So I was kind of lucky with that. Then afterwards, I wrote a small photo application, so a photo viewer, where you can have like a full screen view of your photos. So I didn't really have a good application for that in Linux and with my toolkits. So I wanted to do it in the browser. So I wrote a backend in Scala, serving just the images, and then a front end in ScalaJS. I also had some persistence there to save all like the tagging and the albums, etc., etc. So this was also very, very, very easy, and I'm quite impressed with the speed that you can have when you're building a ScalaJS application. Good. So let's get ahead. Back in the days, Scala used to compile to JVM bytecode, okay, and also .NET, but nobody really used that, I think. And yeah, I guess C# was a better language, and nobody, or not a better language, but better than Java in any case. And many of the features in C#, they were overlapping with the features in Java. So it really didn't really take off. Nowadays, we have a couple of more options. So we can still compile Scala code to JVM bytecode, but we can also compile it to JavaScript blobs, okay? And we can, as of 1 year ago, compile it to native code using the Scala native project. And this is really cool. It opens up a lot of possibilities and writing a different kind of application than we could do before. So this brings me to my second animation that I've been spending quite a lot of time on. So let's imagine this is the sea and the sky. You can see here. Okay. Let's imagine two islands. Okay. And on these islands we have some people. Okay. And to add a little bit to this, and this is just to make things fancy, we had some palm trees and a little bit of sun here. Now, let's imagine that these people, they have to collaborate to achieve some kind of task, okay? Maybe it's building a bridge between these islands, maybe it's building a boat, maybe it's building an airport on an island a little bit far away. Anyway, they have to communicate to be able to achieve this task. And of course, if you're communicating, language can be a barrier. I know this. I kind of came to France 10 years ago without speaking a single word of French, and I can tell you it was quite difficult to get by. So you start by pointing at things, etc., and eventually you manage to speak a quite crappy French, and you continue from there. But anyway, so if you don't speak the same language, it can be a little bit difficult to cooperate. Also, people might have different goals when they cooperate, so it might also be nice to have some kind of overseeing body. Okay? Now, let's say that these people are building front-end, back-end web application. Okay? It would be nice if they both spoke Scala. Okay? It would also be nice if you could have somebody that would verify that whatever we agreed upon for communication between these two is intact, okay? So there we have the Scala compiler, okay? So the Scala compiler can actually do this for us in a full stack Scala project. So that was the end of my application. Another thing that is nice, if you are coding on both the front end and on the back end, is if you have the same language in both places, you will have less context switching, okay? So I think that inside of our head, we have these small kind of compilers, okay? So when we are writing code, we are going to look at the code, we're going to wonder if this is going to compile, and we're going to like evaluate it, okay? Obviously, we are not as good as the Scala compiler doing this kind of tasks, and we spend kind of a lot of amount of time or processing power to do it. So I read somewhere on the internet, so don't take these numbers for certain, but I heard that context switching, it can actually lead to 40% speed reduction, okay? In addition to this, you will have much more errors. You will make mistakes when you do a lot of context switching. So if you have to switch from JavaScript to Scala, and you add to the mix that it's very easy to make mistakes in a dynamically typed language like JavaScript, you obviously are in a bad situation. Yes. No, I don't know. Yes, I was talking about compilers already. So, what have I done? Oh, this is strange. This should... Oh yeah, here we go. So, I've been making a small animation. I don't know why this isn't working as expected. Let's try again. There we go. Okay, so now I'm writing. I've written a small Git-array template that allows you to get started with these kind of projects. So what do you get if you use this template? If you write this command in SBT, so then you will fetch all these dependencies. So HTTP for the backend, AutoWire. So what is AutoWire? AutoWire is a library that allows you to create API that is shared between the front end and the back end. So this is kind of guaranteeing that all your API calls, they are correct. So there's no more thinking about this. There are no more mistakes laying around here. So when you change something on the front end or you change something on the back end, this will automatically show up in your compilation errors or in your project directly. So what more do we have? BooPickle. What is BooPickle? BooPickle is a binary serialization library. So it allows you to serialize everything that is case classes, everything that is standard, Scala types. It automatically serializes it and deserializes it on the other side. And BooPickle and many of the other serialization frameworks in Scala, so this is pluggable with AutoWire. They can be used both on the front end, so they compiles both for ScalaJS and for Scala. This means that you have the same library doing the serialization as the one doing the deserialization on the other side. Okay? So it's almost foolproof, I think, unless there's some bugs somewhere. Okay? So this means that you don't have to worry at all about this communication part. Okay? When you make updates in one side, these are automatically correct on the other side. And I find this is like the biggest advantage with ScalaJS. Another thing you get here is Scala Tags. So this is a way to write HTML in Scala. And CSS, good point. And it's quite convenient as well for doing that. So having this possibility to write this HTML, the presentation logic, in Scala, compiling it either on the for the front end or for the back end, means that you can actually, so you can share this presentation logic, and if the client don't have JavaScript enabled, for instance, you can still serve him a reasonable good version of your presentation logic, if it has JavaScript enabled, you can do enhancements, so you can have bigger speed up, so you can do everything in JavaScript. Okay, so this is the second big win, and obviously I think you can do this with JavaScript as well, so you can run Node.js on the server and thereby do the following. So this is one of the big things of having the same using the same language in both the front end and the back end. So, as I said, you get type safety, you get tooling. This means that you can use, you get auto-completion, you can use the same editor, you can use SBT for dependencies for your JavaScript elements, etc., etc. You got the safety, of course. You have Scala, so this gives you a lot of flexibility for how you write your programs. You got most of the main Scala libraries, they are already available for both ScalaJS and also Scala native. So this means that you can use these libraries in any place. Some limitations, of course. So in the front end, you won't have threading support. So Akka, well, there is Akka.js, so some parts of Akka might make sense, others will not. Streaming libraries as well can also be a little bit limited on the front end. Easy refactoring, if it compiles, it often just works, okay? And I guess you're interested in the part that maybe if you've been doing like GWT before, so Google Web Toolkit, you might have been running into issues where you had a problem and you had to go into the JavaScript and kind of try to figure out what went wrong in the conversion between the two. This is usually not a problem. So I never had a problem about this before the day before yesterday when I was working on this presentation. And then I didn't get the source map, so it was getting a little bit more complex. But most of the time, this is actually working perfectly. So if it compiles, it often runs. And you also have like testing libraries that you can use for testing your front-end application tools. So in addition to this, I guess I should also add some of the problems. So I'm very optimistic and very positive about ScalaJS, but there's a couple of things that can be a little bit annoying. In addition to this issue that I ran into the other day, but slow turnaround. So we all know this. The Scala compiler can be a little bit slow. I don't know if anyone of you went to Mirko's talk about Hydra a little bit earlier. So if you just have a couple of Scala files, Hydra is not doing things so much faster. So I've been using Hydra for a while, but it doesn't really give you like the really fast turnaround that you might want to have when you're doing like front-end development. So that is still an issue. Maybe with Scala C compiled with Scala native, we can get this much faster turnaround for really small projects. I don't know. I saw Dennis. He was tweeting about having this running on some branch, but he don't want to release it or anything. He don't want to share it apparently. Another problem might be like people-wise. So if you have a bigger project, finding Scala developers might already be difficult. Finding Scala developers that are also keen on doing front-end work might even be worse. Okay, I don't know if you know anyone, but so that might be an issue. However, if you're doing both the front-end and the back-end yourself, and you're not an expert in JavaScript, only if you're an expert in Scala, by the way, you should use this approach, I think. Okay. So I think that's all I have of slides. The rest of the time, so how much time do we have left? Where did my guy go? He's proposed to hold the mic for me. Of course you run away. Okay, so let's have a look on the structure of this thing. So, can you still hear me? Yeah. So I'm going to go into full stack. So I did this git new thing. Can you see here? Is this small, right? Yeah. So this is just like a terminal, but let's see. So the first thing I wanted to do was to show you the structure. Oh, crap, what is that? I shouldn't say crap. Let's see if this is working. Let's go into Emacs. So here we can see the slides, the structure of this thing. Can you see this? No. I wanted to change the way this. Oh, this is even worse, isn't it? Wait, this is better. We got there. You can see this, right? Yeah. So here we see the structure of this output of the project you will get. So you have like 3 different directories, or 4 with the project directory, but well, that's like we all are used to with SPT. So you have the GS. Okay, you can name them whatever you want, but the idea is that you have one directory for your front-end code. It's called JS. You have one directory for your back-end code. It's called JVM, and you have one directory which is shared. And shared is going to be compiled by both the ScalaJS compiler and the regular Scala compiler. So you're going to have both of these. Everything that you put in shared will be available both from the front end and from the back end. Then afterwards, in the structure here, we see that we have source main Scala, etc., etc. Okay, so let's go into, let's have a look at something else. So this is my presentation, okay? So we're going to change this a little bit. So I'm going to remove the presentation here. Okay, can you still see? Is it a little bit bigger? Okay, so let's try to recompile this. I will do now a restart of this server. This is going to restart the server. It's going to generate the JavaScript code, and let's see what happens. So, yeah. So here we see nothing, right? So this is the new version. I took away the presentation part. Now we can add some elements to this. Let me get to my help, or let's see. So for instance, we can add an element, h1, welcome to scala.io. Okay, now we have to render this, and we have to add it somewhere. So main div.append child, and let's call this heading. Okay, so we recompile, and we should now see welcome to Scala.io. What? Amazing, huh? So I can see you're impressed here. Now afterwards, what we got in this project, we can look in shared, source, main, Scala, and here we have something called API. Okay, so this API, what is it supposed to do? Well, it's supposed to give us a tweet. Okay, now I can change this. So instead of giving us a tweet, it can just give us a string, and we can have no application. So let's try to recompile and see what happens when we do that. Okay, we get an error. So this brings us to the place where we actually have implemented this API on the server side. So it's called my service, okay? And I'm actually getting tweets here. So let's comment out this code. Okay, and let's create a new def. Get tweet and just return hello. Okay, quite simple. Let's try to compile again. So now this one should be coherent. Oh, I currently forgot some uncommenting. Yeah, right. So great. Okay, we're starting this again. So let's see if something else fails. So this works. So how can we access this from the client side? Well, there is something called the wire. So this is another class that I set up. This is where I set up the front-end part of this spoop pickle and stuff. Can you let me know if it's too small, okay? Or if you have any questions. So this is like an interactive session, meaning that yeah, as I said, I didn't have a projector last time I tried to do this, so this is kind of my first try on it. So here we see there's this wire thing. It has a do call, and the way we set it up. Is this right? Wire.api. Sorry. And then we can now call getWeets. Okay, so we see that this gives us access to the thing, and then we have to do call to actually call it. And this is giving us a future back. And I'm just interested in the success parts. Case, well, S, and what should we do? Well, let's say that the heading equals to S. Well, what do you call it? To string? Yeah. So let's see if this actually compiles. And if we can get the thing from the backend up and running here. You saw that? It's too fast to actually see it. Okay? But what we have here is a type-safe way to communicate between the front end and the back end. As soon as we change something in the front end or in the back end, we automatically got compilation errors. So can we do anything else? So we modify this. The second thing I wanted to do was maybe to draw something on the canvas. So poor Jean, he's exhausted in his arm. So how can we do this? It's only 20 minutes left, Sean. You'll be fine. Good. So let's create an ADT here. So let's call it shape, and we have some implementations. Circle. Oh wait, implementations. How do we do this? Circle. Please enter number. So 3. Great. I think this macro needs some work, but we will get here. So we have a seal trait. Yeah, I did a mistake again. So let's see. There we go. And we go to the end of this line, and we move this one, and we have the case classes. So this certainly needs some work. So circle, it's a shape. Then we have a rect, which is a shape, and a triangle. Okay? And obviously, all of these needs parentheses for being case classes. So how can we describe a shape? If we want to draw it, what do we need for drawing, for instance, a circle? A point, yes. So I'm not going to take the point because we want to animate it afterwards. We want to move it around on the screen, right? This is funny. So I'm not going to take the point, but that's right. To draw it, we need a point. In addition to that, yes, the diameter or the radius. Okay, so I'm just going to use the radius because this is what I have been training on. So for the rectangle, we need height, and let's put them in this order, okay? And we need the same thing for the triangle. Okay, 2 ways to do this when we want to draw this on the screen. So we already have a canvas, I think, somewhere down here. Right, we have a canvas. So canvas is what I've been using for drawing all these things. So either we can have we can use like type classes for drawing any kind of shape, or we can go by subclassing. Subclassing is the easiest one, so I'm going to just do that. And I'm just going to give it a draw, and this is going to be a function, very badly typed function, but still. Animations is, I guess you can do it correctly in a nice functional way, but for the moment let's just reduce the scope here. So how do we draw these? Oh wait, let's take a context. So a context is, what is wrong? Anyone can see what is wrong in this case? Oh yes, I don't need a variable. Right. Of course, this is just the type. So, draw, or, yeah. Good. I mean, that is maybe better. It's a beginner class, right? Huh? Yes. Yes. Thank you. It's good that we have a professional Scala trainer here available at our. Okay, so how do we draw these things if we have a context? So take a circle, take the context, and oh wait, you also said another thing. We need a point, right? So I'm going to pass the point when actually drawing it. It's a point of type point. Let's see, we don't have a point class. So what is a point case class? Point x and y, like this. Okay, so we take a point, we take a context, and now we should be able to draw this on the context. Point. Okay. This is the problem with live coding. Type point. You always mess up. Okay. So that's good. Triple question mark, and let's see if it still compiles. Yes. It looks good, doesn't it? Well, not yet, because we don't have the draw here. So what do we do with the context? We do begin path, okay, and afterwards we do context dot close path, and then we do context dot fill, and that should be all. Now we just need to supply the actual path, and to do that we can use the arc here. So this takes x, y, so x will then be the point dot x, y is going to be the point dot y, the radius, which is radius, the start angle, and I think this end angle, so here we can have 2 times math dot p, right? We need 0. Okay, great. So, should we try this? Any double? Ah, yes, thank you. Okay, let's try to copy this. Okay, copy pasting is not necessarily very good, but I probably will regret this copy pasting soon enough. Okay. And let's try to draw something on. So I'm missing some end braces here, and probably here as well. Okay, I think we are good now. Let's try to compile it. I don't have the point. Yes, I have the point. Yes, right. So let's comment out this. Let's just delete it, and let's just delete it. So as I said, copy pasting is bad. I will regret this, and as you can see, I already did. Okay, so it seems to compile, Now we just need to draw it. So new circle. So let's give it 400. And then assign this to a variable. And we do c dot draw. We pass it the context. And I think I have a thing called, yeah. Oh. Thank you. I have someone shout. It's giving me some hints here. It's very nice. Let's see if this works. We don't have the context. It's the forward reference. Yes. Okay, so let's move this further away down here. So do you think this will work? As I said, if it compiles, it works, doesn't it? Wow. Okay, a little bit big. It's a little bit off-centered, but still, it's kind of nice. How much time do we have? Still some minutes. Okay. We can add the other ones. So what we need for, in this case, so the rectangle is, let's just copy it from my help shapes here. And I also want an input field where I can do things with these shapes. And let's see, like this. And when I'm doing something here, I want to def parse input. And I'm going to copy this as well, okay? So I have this random point method that I can copy in here. And this is going to give us like a point somewhere on the canvas. So it's nice. So if this thing, so if you look at this string here that comes in, parse input takes a string, and we're doing pattern matching on the string. Okay, so we can then add a regular expression. I did some keyboard setup. So if we get circle with some amount of D's here, so some digits, and then, I don't know, a color. So dot. Are you okay, Jean? And we turn this to a regular expression. Okay, so case circle reg, and here we can now capture the groups. So this is going to be the first group, and this is the second group. So this is the radius, and this is going to be the color. Okay, so now we can draw shape. Oh, circle dot radius dot. Am I losing myself here? I miss an arrow. Where? Yes. Right. And I also need a point, so I'm going to use my random point. Huh? Oh yeah, right. Good. So this is the problem with live coding. Never do live coding. And I need a context. I should have made the context implicit. That would have been much more implicit to live code. So this should work, right? Let's try it. Oh no, it doesn't. It's too early in the morning. We don't have the random points. We don't have anything, maybe. Okay, let's put it down here. Let's see now. I see I still have some problems here. I need to point us somewhere, so let's say, let's just be a place. And this needs to be an int, so I guess that is, we already know that this is an int, so that is probably safe to do. Not found value, next int. Okay, so this is import Scala util random dot next int. Okay, let's see. Still problems. It's too early still, yes. I should. Okay, will this work? Still forward references in parse. Right, forward references. Because what are we doing? We are calling this parse input from, yes. So this one has to come at the end. So where is it? The input. It's complicated writing Scala code. Should go with JavaScript instead. Okay, now hopefully we will have a small field here. No, we don't. Where is it? Is it hidden? Yes. Oh wait. What is that? What did I do now? I kind of followed some. I did some keyboard shortcuts. Bad idea. And this one is not responding. HTTP. Did I type this correctly? Localhost? Oh. It's always something, right? And there it is. This matching thing I should take it away. So let's remove this circle that we have, and yeah, this one, and somehow, okay, no, hopefully this will work again. And it's coming. It's coming. Oh no. Where is it? I didn't add it. We didn't add it. So we have this input field, and we just need to add it. So main dot main div dot append child, and we add this input f. Okay, so that explains it. So here it would be nice for the presentation to have a faster feedback loop, right? So this is what I talked about earlier. So now hopefully, if I write circle 200, oh no, it doesn't work. I'm sorry. Points. It's a good point. This is nice to have the people in the crowd that are following. Yeah. Amazing, right? In addition, we could maybe add a color and stuff, and we could have more fun with this. Thank you. 3 minutes. Okay, so I had a little bit longer presentation. Coming back to this being a time optimist, I always think that we have the time to do more things that we want to do. So I was kind of thinking that we would connect this with server-side events. We would be able to parse tweets coming directly from you guys, mentioning rectangles, triangles, and circles, and we would be able to draw these tweets on the screen automatically. But unfortunately, time is running out, and if you like, we can sit down and do this afterwards. I've already been doing it at home, so even if it doesn't look like that, it's just the nerves. Questions? Yes. Yes, right. So we have a spree on Friday, and apparently I have the invitation to come and do the rest of this at that point. So if you're interested in ScalaJS, and you can also join, you just have to do SPT new and the Giterate templates, and you're almost ready to go. Okay. Questions? Yeah. Yes. 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 So this is a very good question. The question was, what you've shown us is just using the standard JavaScript API, and you haven't been using any external JavaScript libraries. So the question is, can you do that, and how do you do it? And the answer to this question is yes, you can do it. Interoperability story is very good. So if you take a JavaScript library, you don't get the typing information, right? For normal cases. So in this case, you would have to type things without the guarantee of actually having the right API. However, people have been providing facades for many common libraries. So there are ScalaJS facades available for React, for a lot of different common or interesting libraries. So if people have been using it before, they probably provided a facade that at least give you some bindings, some ways to use it, and also in a more Scala, better Scala fashion way. So, but yeah, it's also very easy to set up these type-safe facades yourself. We can also do a little bit of that if you come to the spree. Okay. Any other questions? Yes, in the back. Yeah, so I might not have been touching enough on this. The thing that you do when you're compiling this is that you have this API, and this API is shared between the two projects. So it's actually compiled by both the ScalaJS compiler and the regular Scala compiler. This means that it will verify both ends. So if you made a modification to your front end, you also have to make a modification to the shared part. And this is also going to be compiled by the backend, therefore you will see errors whenever you're introducing them. So typically you will introduce errors in the shared part that is breaking things. But yes, so this is the magic of it, as I find it, is that you have all this available. Yeah. Yes. Yeah, so here it said that you can also integrate your existing ScalaJS code into JavaScript code base. Yes, you can. Yes, with npm, and you can export parts of your application. So ScalaJS by default is creating a big blob of JavaScript, and you have this main function that is run that you evaluate. But you can also add additional endpoints to it, so you can expose functions to JavaScript. So you can call into a ScalaJS project using different endpoints or whatever you call it. Time is out. Okay, please come and talk more with me if you have more questions. I really recommend this project. It's really amazing for productivity, so try it out.